For this lesson, we're going to be discussing like terms and the distributive property. So if we look at a like term, that is any part of an algebraic expression that can be added or subtracted together. So maybe starting with this first one here, there are 4 terms in this expression. Those are things that are separated by plus or minus signs. And a like term, I'll underline them. If we check out 2x, that can be compared with 3x, and the reason is the variables on them are exactly the same. So we have 2 of something, we have 3 of something else, that means we can combine those together. If we look at the 5y and the 0.5y, so those 2 terms are also like terms. Again, the 5 and the 0.5 are just telling you how much you have, but you're saying how many y's do I have? So let me list these off to the side. Okay, so for the like terms, we have 2x and 3x, as well as 5y and 0.5y. Now in our second expression, so this thing here, the like terms they look a little bit more complicated, but the idea is the same. All we have to do is look at the variables, and the variables have to be identical for terms to be like terms. So if I start with the 15xy, the 15 I can kind of ignore and focus on just x and y. If I go to my next term, I have xy squared, so they're not exactly the same, so these two are not like terms. If we now check out the x cubed, okay, there's no y's in there, so that can't be a like term with 15xy. And then at the very end, we have xy squared. Again, it's not exactly the same as this xy. So 15xy cannot be compared with anything else. Now, if we check out the next term, 4xy squared, I can see that we have these other xy squareds at the very end. So we have 4 of one, there's 100 of the other, but it's the xy squareds that are identical. So I'll list that off to the side. We have 4xy squared and 100xy squared are the like terms in my second expression. The last one really to focus on is this 27x cubed, and for the same reason, this can't be compared with any of the other 3 terms because there are no other x cubes. So for example 1, what I'd like to do is now combine the like terms in order to simplify the expression. So if we look at part A, so we have a 2x and a 3x, and you can just add the coefficients together to give us a total of 5x. And I'll repeat the same thing with the y's. We have negative 5y and minus 0.5y more. I'm really just focusing on the numbers at this point. If I take negative 5 and I subtract 0.5, I get negative 5.5y. So we've simplified the expression by combining like terms. So now we have x's and y's, but those cannot be compared and we can't take this any further. Now if we check out part B, from our previous work, I know that the only things that we can combine are this and this, but the idea is the same. I'm just going to now compare the numbers that appear in front of my variables. To start this one out, I'm going to write down 15xy, and that's just going to stand alone. It can't be combined with anything else. But we have negative 4xy squared. I'm subtracting 100 more. That's going to be minus 104xy squared. Now we have this negative 27x cubed. That can't be combined with anything else. So here we go. This is the final answer. We've combined all like terms, we've simplified the expression, and that's it. For the second part of this lesson, I'd like to discuss the distributive property. This gives us a way to multiply something into a set of parentheses. So the property itself at the very top here, we have a times the expression b plus c, and that's equivalent to ab plus ac. It's called distributive because this a gets multiplied to the b, that's why we write ab, but it's also multiplied to the c, and that's where this a times c comes from. Since we're separating by a plus sign, we'll put that plus sign in the middle, but we're going to use this in example 2 to multiply into a set of parentheses. Let's start with part A. So here we have 6x times 3x plus 2y. So this property tells us that we can take 6x and first multiply it to the 3x, and then second multiply it to the 2y. So I'll be careful in writing this out, but that's going to be 6x times, I'll use parentheses and say 3x, then plus, okay, I get 6x again, and with parentheses I'll put 2y. So really we've done it. We have now multiplied the 6x, which was outside the parentheses, into the expression. All we have to do now is maybe simplify it and combine like terms if any exist. So for the first part here, I have, let's see, I'll deal with the 6 and the 3. I know that's going to give me 18. And then we have x that's multiplied to x, which if you'd like, you can write as, well, that's x times x. For the second part, we have 6 times 2, so I'll write that as 12. And then again, here we have an x times a y. I think I'll just place those next to each other like this. And so far it's simplified pretty well. I do think we can take it one step further. I'm noticing that we have an x times an x, and those are both to the first power. We can move this further by saying, okay, that's 18 times x squared. You're saying you have in total 2 of them. And so I'm using an exponent of 2. For the next piece, which is 12xy, well, x and y are different, so you can't use the same rule here. It would only work if the base was the same. They are different, and this is our final answer, 18x squared plus 12xy. So for part B, I'm going to do the exact same thing. I'm just throwing in, now there's a negative that appears outside of the parentheses. So we have negative 2x, I'll put times 1. Now, anytime that here we have this negative outside and there's a positive inside, I know that's going to switch to a minus. And then I'll put 2x times x squared. So going back to the original distributive property, there was a plus sign that appeared in both parts of it. But if a negative shows up, it would just switch that sign from positive to negative. So continuing along here, negative 2x times 1 is just negative 2x. Here we're going to have a negative, and we have 2 times x. Maybe I'll put an exponent of 1 on there and then write x squared next to it. To simplify this, I'll do what I did in part A and write this as negative 2x minus 2 times x to the power of 3. So I'd say this is completely simplified and there are no like terms to consider, so that's my final answer, negative 2x minus 2x cubed. And as a final example here, I see that this last set of parentheses has 4 terms in it, which again doesn't look like the original rule, but if there was a 3rd, 4th, or 5th term, we can just keep applying this process where I'm going to take the 1/2 y and I'm just going to multiply it to every single term that appears inside the parentheses. So there could be 6, 7, 8 terms, but you just keep going until you get from the start to the end of it. So all right, for this one, I have 1/2 y, and then I have 8y cubed. I think for this, I'll put the 8 over 1, the y cubed at the end, just because I'm going to start comparing fractions, so why not put a fraction for 8 over 1. Okay, now I have minus, we have 1/2 y, and then again I have now 4y squared, again using a fraction. Then it'll be plus 1/2 y times 2 over 1 y. And then lastly we have plus, again, 1/2 y. And then this is just a number. I'll write 10 over 1. So again, just distributing the 1/2 y to every single term in the parentheses, even though there's 4. Maybe I'll rewrite this. So I'll place the fractions next to each other. So that's 1/2 and then 8 over 1. And here I have a y to the first and a y cubed. I know that's going to go to y to the fourth just by adding the exponents. For the next piece, I have 1/2 times 4 over 1. Here I have a y to the first times y squared, so that gives me y cubed. Okay, next I have plus 1/2 times 2 over 1, and that's a y to the first times a y to the first. That gives me y squared. And then for the last piece, there is a 1/2 times, this is 10 over 1, and there's just the y at the very end, that y to the first. To complete this problem, all we need to do is simplify the numbers that appear in front of all of the y's. So I'll start with the first one. 2 goes into itself once, it goes into 8 4 times, giving me 4y to the fourth. Then it's going to be minus, all right, 2 goes into itself once, it goes into 4 twice, so this is going to be 2y cubed. Here the 2's cancel. That entire coefficient is just going to be 1. I'll write just simply y squared. And then for the last piece, we have 2 goes into itself once, it goes into 10 5 times. The number that's left over there is going to be 5 times y. You can write the 1 or not. I'll choose not to, and this is the final answer for that last part. So the point here being, for the distributive property, it doesn't matter how many terms you have. You just keep multiplying until you multiply to every single term. Then here I applied a couple of rules of exponents and simplified my fractions, and I had my final answer.